Hello everyone, welcome to today's live stream. So we finally actually have a rocket that's most likely going to go off today. It's been a bit of a annoying couple of weeks. We've had quite a few scrubs on a lot of rockets. But yeah, so we have a Rocket Lab Electron flight today. Just want to say, if you hear me getting a bit bunged up and that, just getting over COVID, so good old fun bit that. So yeah, we are just waiting for Rocket Lab to start their oh, look at that, just as I start saying it, I'm going to put their sound on for you guys. Here we go. Right, I'm going to just turn it down a bit because it's shouting in my ears. But yeah, here we go, right on time. Oh, look at that. So this will be the, where is it? I got it here. 300th Rutherford flight engine. So basically their engines have now flown 300 times. So they've flown 300th engine. So that's cool. Oh, you know what I forgot to put on? I forgot to put on my text-to-speech. Right, let me just open another.
Hello from Rocket Lab's Mission Control Center. We're live with a view of Electron on the pad at Launch Complex.
There we go. T-minus just under 20.
Electron mission, a dedicated launch for Japanese Earth imaging customer Synspective. My name is Felicity Powell, and I'm so glad you could join us for this landmark mission today. T0 is currently set for 0838 local time, and as this will be an instantaneous launch window, we have just one chance to fly per day.
Oh dang.
However, if we do need to stand down for any reason, we have plenty of opportunities over the next 13 days as a backup. If Synspective sounds like a familiar name, it's because they're a return customer to Rocket Lab, with today's mission being Synspective's third mission on Electron. We first launched for Synspective at the end of 2020 with the Owl's Night Begins, our 17th mission, a dedicated Electron launch of Synspective's cutting-edge Earth observation satellite, Strix Alpha. And then earlier this year, we launched them again, this time part of a 3-launch series of Synspective's Strix satellites with the Owl's Night continues. The 24th Electron mission was also the first launch from Pad B at Launch Complex 1, which we'll be launching from again this morning. Operating 2 pads at Launch Complex 1 doubles our launch capacity and eliminates pad recycle time, since we can switch between pads, enabling back-to-back missions like our recent missions for the NRO. Today's mission is called The Owl Spreads Its Wings, and it's carrying
this name.
Synspective's first commercial SAR satellite.
Satellite
the owl is a symbol of wisdom
imaging
and luck
SAR
in many
SARs.
cultures, including Japan. Owls also have
remember.
binocular eyes, much like we do, which gives them excellent visual acuity to judge height and distances. They have extraordinary night vision and the ability to see small details from far away. Barn owls of the Strix genus can also use their asymmetric ears to hunt using sound. In a similar way, the synthetic aperture radar technology on Synspective's satellites, known by the acronym SAR, uses the echo of radio waves to create 2- and 3-dimensional images with millimeter-level resolution of the Earth's surface. Because the technology does not rely on visual electromagnetic wavelengths, it can produce these high-resolution images regardless of cloud cover or daylight. This resilience makes the Strix satellites ideal for complex tasks such as disaster response in all conditions, monitoring flooding and inclement weather systems, urban development and planning, and construction and infrastructure monitoring. Let's learn more about Synspective.
Oh, here we go. So this is about the satellite itself. There it is. I like the little tune on this, it's good. That is pretty cool. So they want 30 satellites by 2026. Not bad. I like this little catchy tune. Oh man. Oh, I've got a itchy head. But today's drink is milk with 2-bite brownies because, yeah, got them from Costco. I do quite like this little jingle, it's pretty cool. Oh. Okay, are they just gonna... I mean, it does look pretty cool. Disaster Management Assessment. Okay, so it'd actually be able to tell, like, in the background you've got the rock slide sort of thing. So you'll be able to see where it shifts. Okay, that's pretty cool. One thing I need to do is just keep it on 1080p. YouTube just decides for a split second it's just going to drop me down to 480. No idea why. It's very, very cool. It's amazing how they come up with this sort of this sort of technology. It's crazy. Oh, just gonna sneeze, guys. I'm back. That may have hurt my shoulder, but oh, here we go. Come on.
Today's mission isn't the last time we'll see the Owl taking flight from Launch Complex 1, with another sensational mission already booked for next year. Now we're coming up on the T-minus 12-minute poll when our operators will run through the go, no-go calls with the launch director.
Oh, this is where we need to hear it.
Control to wait for the call.
Here we go. I'm going to put my headphones on properly for this. Pardon me. Come on.
In all stations proceeding with the go no go sequence. Stage.
Here we go.
Stages go. Avionics.
Avionics is go.
GNC.
GNC's go.
Econ.
Econ is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
I'm trying to find them in the room.
Met is go.
MM.
MM is go.
LD sub.
LD sub is go.
Okay, that is the go no go sequence complete. We are T minus 11 minutes and 16 seconds and counting.
Alright, oh, wow. We are go for flight. Nice. That's good.
That's confirmation from Mission Control. All systems are healthy, and we're proceeding with the remainder of the count. T0 is still targeted for 0838 New Zealand local time. It's currently 8:27 local time, and we are 10 minutes away from liftoff from Launch Complex 1. Now, Launch Complex 1 was the world's first, and is still the only private orbital launch complex. Established in 2016, we have now launched 29 times from this location, soon to be 30 with today's mission. We also have our second orbital launch complex on Wallops Island in Virginia, which is slated to launch its first Electron flight in December this year. We're excited
Cool.
to
It's quite windy.
be debuting Launch Complex 2 and can't wait to share more about our plans at Wallops, with our new neutron production facility and launch pad being established on the island as well.
It really
Here's
looks
our
windy
VP of
there.
Launch, Sean DeMello, with more on LC1.
Launch Complex 1 is like no other launch site in the world. We literally started on a green field here in Mahia Peninsula, built one little pad and a small integration facility, and now we have 2 pads, a number of clean rooms, making a world-class launch facility.
It does look really nice, actually. Oh dang, they got some good music going on. Alright, I think I'm gonna chuck myself in this corner over here.
We created a launch complex that was capable of launching once every 72 hours to a range of inclinations, right from mid-inclination, about 30 degrees, all the way to sun-synchronous orbit, all from Launch Complex 1.
Well,
So
they
with
can do
Pad B,
some
we took
synchronous
a lot
from
of the design
there.
from our original Pad A and made some small improvements to make our operation that much more efficient. We use the same integration facility, the same rocket runway, with our final infrastructure all placed in a concrete pad no more bigger than a tennis court. With 2 launch pads, we have doubled our capacity and reached ultimate launch flexibility. This means when a customer needs us, we've got a pad ready. From LC1, we've flown over 100 satellites to date, all supporting everything from climate science through to international logistics, maritime surveillance, to the
Very
moon and
cool.
beyond.
I wonder if they're gonna try and catch the boosters again. Because I know they were trying to do that.
It's been his high powerful flight.
Can-
Stage LD mission.
Because they tried to catch one with the helicopter,
Proceed with sequence 57, the stage terminal checks.
Proceed with sequence
and then they
57.
gave up, and we haven't really heard much about it since then. So I wonder if they've... Let me just sort out this bloody green screen. There we go. Yeah, we haven't heard anything about them trying to catch the booster out of the air. So I wonder if they're going to carry on doing that, or if they scrap that
GC
idea.
mission.
LDGC.
And proceed with sequence 58, launch pad ready.
Roger, proceeding with launchpad ready.
Damn! Launchpad is ready.
Stage 1 and stage 2 high voltage batteries ready for flight.
Nice. Will it go boom?
All engine blips.
Yeah,
are
let's
now
chuck that in the
launched to
chat.
LD stage mission.
Stage LD.
Stage terminal checks are complete.
Copy, thank you.
There you go, that's up in the chat. Yeah, what's going on? Oh, we have... Someone's already put no. Oh, someone's just put yes. Well, we have a 50-50 at the moment.
As we prepare for launch, we're checking off a few more achievements for the year. 2022 has already been packed full of milestones. Our first launch from Pad B in February, our first helicopter catch recovery mission there and back again in April, and the success of the capstone mission to the moon for NASA, the first step in the Artemis program in July. Today's mission is also a landmark for our Electron program, including the 300th Rutherford engine we've flown to space and the 150th satellite delivered to orbit.
So they've done 150 satellites. That's mad. Love you too, Dad.
Recently, we also conducted the first hot fire of one of our recovered Rutherford engines from the There and Back Again mission, another milestone involving Electron into the first reusable small orbital launch vehicle. Let's take a look.
Yeah, so this was a test of an engine that they got off one of their old rockets.
The movement of that engine is just part of our nominal test profile. With this milestone now complete, the next recovery mission is coming up later this year, and yes, we are bringing back the helicopter. So stay tuned for more details on that mission.
There we go. They've just answered my
Speaking
question.
Of milestone achievements, earlier this year, Rocket Lab held a groundbreaking ceremony for our new Neutron production complex and launch pad, which, as mentioned before, will be in Wallops Island, Virginia. Neutron is Rocket Lab's next generation launch vehicle in development, designed to lift 8 tons of payload and to provide a tailored launch solution for satellite mega constellations. As a reusable rocket, Neutron is designed to land back on the launch pad after a mission, and from there it would be returned to the production complex for refurbishment and reflight. While today's mission will lift off from
Falcon
Complex
9.
1, we'll soon be seeing a different view as we prepare for our first mission from LC-2 in Virginia. That mission, for our friends at Hawkeye 360, is currently scheduled for launch in December, and we cannot wait to see Electron headed to space through Virginia's skies.
Yeah, that one
With
would be
that
quite
mission,
nice.
we'll be launching Electron from a total of 3 pads, supporting a rapid launch cadence and offering our customers flexibility over their launch location and orbits.
That is pretty mad, actually.
We are now moving towards the final stages of liftoff with T-minus 4 minutes remaining on the clock. At T-minus 2 minutes, Electron moves into terminal count, and the rocket's flight computers take over the countdown. Shortly after the 2-minute mark, we should hear the call that liquid oxygen loading is complete, which means that the vehicle is fully fueled and good to go.
It's taking off from New Zealand.
That the first and second stages are pressurized for launch, and finally, we await the 10-second countdown to liftoff with our launch director, Joseph Carpico. Let's listen in to Mission Control for these final steps ahead of liftoff.
Yes. Oh man. So yeah, it's all from New Zealand. This just off the peninsula. I can't remember what they called it now. I literally just said it, but yeah, it's quite a good little launch site. To be fair, they got 2 pads right next to each other. Like when we look at Kennedy Space Center or anything like that, there's 1 pad, and then there's about 10 miles. Then there's another pad where this is literally one there. What, 500 yards? There's another one.
On mission from now on, there should be no red flags on your critical LCCs.
Ooh.
Beacon LD mission.
LD Vicon.
Confirm all expected flight computer ASGOs are green.
Confirmed ASGOs are green.
Here we
Please
go.
Lock the auto sequence and confirm.
Confirmed auto sequence is locked.
Okay, we're go for auto sequence start at T-minus 2 minutes. LD is go for launch. LD Shadow, confirm, go for launch.
Nice, we're gonna go. Come on, no scrub. And it's an instantaneous launch, so they have to go on T0. No matter, you know, if they have a problem, it scrubs for the next day. I think they got 13 backup days, the next 13 days. So, which we don't want it to scrub, because, you know, we want to actually see a rocket take off this month. Yeah, it's been a very hard time, but yeah, the Falcon 9s
Vehicle is switched to internal power.
keep scrubbing for weather. Has been
power disabled. Vehicle is fully on internal power.
it's been horrible
AFT is
storms
and enabled
at
for flight.
Florida at the moment, so they've not been sort of doing stuff with that. Let's turn it up a little. There we go. So,
Locks look complete. Lock system in recirculation.
so that's what you can see with that little vent there. That's the liquid oxygen just basically it's got to the top and now it's venting out, and they basically do that until engine chill, and then they stop it.
All helium anti-geysering disabled.
There you go. You'll see it sort of puff out every now and again, because that's just it getting to its very top, the right pressure, and then it gets a bit too much, so then they got to vent it back out. And oh, look at it. Let me get my mouse out of the way.
Stage 1 and Stage 2 tanks suppressed.
Oh, come on, please. I want to see a rocket launch this month.
High flow engine purge enabled.
It's the 15th of the month. Like, halfway through a month, and we're only just starting to get to see a rocket launch. Right.
Water deluge is activated.
Yes. Here we go. Right, I'm going to get my hand on the
T-minus 20
volume
seconds
button.
and counting. Ten, 9,
Here we go.
8, 7, 6,
5, 4,
four,
3, 2, 1. Oh, they're going for it. Yes! We actually get to see a rocket take off for the first time in September. At least a US or a New Zealand one. China have been sending off theirs absolutely fine. Oh, finally. I got a headache.
Stage 1 propulsion.
Our 30th Electron has taken to the skies, having successfully lifted off the pad at Launch Complex 1. You can see the distinctive shape of the Mahia Peninsula below, as the vehicle is
I
on
think
its way to
it's
space, carrying our 300th
North
Rutherford
Island,
engine and
I think.
150th satellite. The next critical stage in Electron's flight is Max Q, maximum aerodynamic pressure. This is when the vehicle's velocity and local air density are at their maximum, and the vehicle experiences the most mechanical stress.
Here we
We'll hear that call
go.
from Mission Control when Electron clears that stage of flight.
Yeah, I believe it's the North Island that they're on.
Max Q.
Because it's sort of top right up here.
Electron has successfully passed through Max Q and at an altitude of just over 15 kilometers is well on its way to pass the Kármán line and enter orbit.
Nice, here we
The
go.
9 sea-level Rutherford engines on the first stage are operating nominally, and we are approaching the next series of events in the mission. The first step after Max Q is MECO, or main engine
cut-off.
when those first 9 engines throttle down before shutting off completely. This slows the vehicle marginally before the first stage separates from the vehicle. Once this is complete, the second stage space-optimized Rutherford engine ignites to take the payload and kick stage the rest of the way into orbit. These 3 events happen in quick succession, so keep an eye out and listen in for the call from Mission Control.
Look at that.
Roughly 30 seconds.
How far the exhaust plume is coming out. Oh, it's over here, isn't it? Yeah, the exhaust plume is so far out now. That looks so cool.
15 seconds to Miko.
Oh. There we go. And we should have Miko any second.
MECO confirmed.
Stage separation successful.
Nice.
Stage 2 mission confirmed.
Oh wow. Bit of a delay on them, but you know. Oh, look at the booster
Done,
just
done,
falling
and
away.
done. With that, we've confirmed MECO, stage separation,
That
and
looks
ignition
so
of the
cool.
space-optimized Rutherford engine on the second stage. At this point, as Electron has cleared most of Earth's atmosphere, it can also jettison the payload fairing, as it is no longer needed to protect the payload.
Come on. Where's the fairing gonna go? Are you gonna show the fairing? Oh, there goes the fairing. So where's the other one?
You can see it there on your screen.
Oh, there's both of them.
Electron's fairing has now been ejected, with the 2 pieces falling away. Electron's second stage is continuing nominally on its way to orbit, carrying its inspective payload, which is now exposed in preparation of deployment. The vehicle is currently reaching speeds of more than 8,000 kilometers per hour and an
Damn.
altitude of 131 kilometers.
It's going pretty damn quick. Look how hot the engine bell is.
The vehicle is continuing nominally on its flight to low Earth orbit, currently traveling at a speed of over 9,000 kilometers per hour and an altitude of 140 kilometers. As Electron lifted off the pad, you would have seen big clouds of what looks like smoke billowing out from under the vehicle.
It's not,
That's
it's
actually
steam.
Steam, produced as the exhaust of the engines makes contact with the water deluge. We use water to absorb the immense sound energy produced by those 9 Rutherford engines at liftoff.
So it's almost where is it right now? 160 is that kilometers? Yeah, kilometers high. So 160 kilometers high and still going.
We're now almost 5 minutes into the mission for the Owl spreads its wings, our Electron flight for Synspective. The vehicle with payload is traveling at a speed of over 11,000 kilometers per hour, currently at an altitude of 176 kilometers,
Yeah, it's
well on
mad.
its way to low Earth orbit. The low Earth orbit zone, often noted as LEO, is classified by having an apogee of less than 2,000 kilometers,
Yeah.
or approximately 1,200 miles.
We have Leo right here, Leo the bear. He's our low Earth orbit teddy. Even though it's my wife's from like when she was a kid. She just liked the name Leo. Come on. Can it go boom? Oh.
Next up is a step we refer to as the battery hot swap. The Rutherford is a unique engine in that it is powered by electric pumps, which draw energy from batteries. Once those batteries are depleted, they're just dead weight, so we shed them to swap out for a fresh one. If you watch carefully, you'll see that shiny silver battery separate
Just
from
there.
the Electron soon.
Just see him go whoop. Oh, whoop
If
that
the
way.
battery discharge holding nominal, reaching hot swap in roughly 30 seconds.
Throttling down.
It's pretty cool actually how they do this. Yeah, because there's no point in holding on some batteries when, you know, if it's going to make your craft lighter. There you go. And they just burn up in the atmosphere. Not many people will see
You might have seen
that
it there.
happen.
Battery hot swap has been successfully completed, and a new battery is powering the second stage onto orbit.
It's mental. It just swaps over like that. And there's a physical connection cut. It's crazy.
Our 30th Electron vehicle is in the air and on its way to space, continuing our mission to make space accessible for all. We're also on a mission to make the space industry accessible to all, with
Yeah.
more opportunities and pathways into careers with Rocket Lab than ever before.
Oh, can I get a
It's never
career,
too late
please?
to consider an old dream or a new aspiration and reach for the stars with us. Check out the careers page on our website, or if you're not quite ready for recruitment, our education programs will help get you there. Go to rocketlabusa.com to find out more.
I'll be a test dummy. I'll stand on top of the new rocket while you launch it. I'll be well happy with that.
Battery discharge holding nominal.
Everything nominal. I just think it's 8:30 in the morning. 8:30. No, almost 9 o'clock in the morning over there, and it's
Electron
quarter to
is
10
currently at an
at night
altitude
here.
of 206 kilometers, traveling at a speed of over 19,000 kilometers per hour on its way to
Damn.
space. While this particular mission is not a recovery mission, our recovery program is progressing at speed, with the first test of a recovered Rutherford engine just 2 weeks ago, and it was a roaring success. We're looking forward to the next 30-minute missions and beyond, perhaps even flying fully reusable hardware to improve sustainability and value for our customers.
Oh god, I'd hate to be the first customer to do that. That you know SpaceX can do it, but it's can these smaller launch providers actually make it work?
The next major milestone we're approaching is second engine cutoff, or SECO. Just like Miko, our space-optimized Rutherford engine on the second stage will throttle down ahead of separation from the kick stage, which takes the payload to exactly where it needs to go.
It's very cool.
Guidance is in total, 27 seconds remaining.
20 seconds to go. We got 21 seconds to go. God, it's going so fast. You imagine seeing something going 27,000 kilometers an hour on the ground. Like, it's mental. Like, you wouldn't even see it. It'd just be, it'd just go past.
Seco confirmed.
Seco, nice. Yay, we clap, everyone clap.
You may have heard the call there. The vacuum-optimized Rutherford engine has throttled down and the kick stage has cleanly separated from the second stage. From here, the small but mighty Curie engine will take the payload to its exact destination in space. For the next 50 minutes or so, the kick stage will enter a coast phase until it reaches the apogee of its elliptical orbit, the furthest distance away from Earth. From here, the Curie engine kicks in to adjust its perigee to a circular orbit at this point. Once it reaches the orbit our customer has requested, we'll deploy Synspective's Strix-1 satellite to its new home in space. We won't have a live video feed from the kick stage on this mission, but we will stay with you on this webcast to bring you a simulated view of payload deployment. We'll take a bit of a break on the webcast now, but we'll be back with you closer to payload deployment to listen in on those final moments from mission control. This last step in the mission is expected to take place at T plus 53 minutes, and we'll see you back here then.
Okay. Right, I was actually going to say, this is where it is. So it's North Island, and it comes shooting down, and it goes over the Antarctic and back up. Basically, it kind of goes between us and the United States over the ocean. So, and all these little points here are their radar stations, which is very cool. But yeah, I think so that's 40 minutes. Yeah, I think I'm gonna end it there, guys. It's quite a long live stream, and I don't really fancy doing the whole thing today. But yeah, that was a good little a launch. It's nice to actually see something take off finally for the first time in September. We do have a later live stream tonight. Was it 2:15 AM British Summer Time? So 1:15 UTC. But yeah, that should be fun. Hopefully they don't bloody knock this back down again from last 3 days. They keep knocking it back due to poor weather. But yes, and as my shirt says, well actually, as I say, I'm Lee. Fly safe, land safer.